Hello, everybody. So I wasn't entirely sure what the audience would be for this. So what I put together were just some kind of extended slides from the quick introduction I gave earlier that give kind of more complicated use cases. And then a walkthrough of kind of the built-in tutorials. So both of these languages have like built-in tutorials where they set up a problem for you to work with, and then you can implement it and then build in and run it. I can walk through those. That being said, if you're more advanced users and you want to kind of focus in on something, we're also here to help. Several ALCF people in the meeting. I developed on Raja, and Evan develops on Kokkos, so we get through all that. So if I don't hear anything, I'm going to go through some of the more complicated examples just to give you more of an idea of what you can do with these languages. And then set you up if you want to try to play with it with the examples they provide. Depends on those. Okay, Kokkos. Just coming back, we went through this example earlier, just to see what a Kokkos implementation will look like. So you have your pattern, you get a string label that you can attach to it, so you can debug it. Execution policy, just kind of defining your iteration space, your index iteration handle, which is how you access into your iteration space, and then your body, which here you're using the Kokkos views. So looking at something more complicated and is most likely going to turn up if you're kind of doing a simulation code is reduction. So there's built-in support for reductions in Kokkos. This is one of the nice things. It's kind of a big surprise they don't have it in CUDA, but there's basically built-in support for reductions, and you kind of specify it easily, more like an OpenMP reduction. So see here now, instead of parallel for, we're doing a parallel reduce. And now there's a second argument being passed into Lambda. This one's getting passed by reference, and that's the sum variable. That's the thing that's going to be reduced. And then you'll see there's an extra argument going into the parallel reduce, which is basically where you want your result to go. So that's kind of a slightly more complicated version, but still it doesn't seem like that big of a change. Now let's go to something even more complicated, do a sparse matrix vector multiply. We're going to be looping over rows, then do a dot product to your matrix row with your vector. It's an example of non-tightly less loops because we have these a couple of lines in between the outer loop and the inner loop. And also there's going to be random access on the vector, which you can use a textured fetch on the GPU. So here's a Kokkos implementation for it. Again, we're using the Kokkos views for all of our accessing. But now we're going to split down the parallelism. So we're going to do team parallelism across row work sets. So here we're giving the name again. We're doing a team policy, basically saying statically schedule this. And then inside, we're able to define another parallel for. This is going to be distributing the rows and work set over team threads. And this will allow you to kind of define arbitrarily nested parallel regions, which Kokkos is going to compile down into something that runs pretty well. Whereas if you try to do something like this kind of naively with OpenMP, you might end up over scheduling everything if you're doing hierarchical parallels. And finally, we're going to have that inner loop running a parallel reduce, which is basically the same thing that we just saw last week. And then I mentioned the textured fetch, so you can set the kind of memory access traits for this X so that it's going to be using the textured memory on the GPU. Okay, so if you want to get started, you can do this on Polaris. Ran through these, they are working. If you're trying to enable an existing project, there is a Kokkos module available on Polaris that you can just load. This is going to use the Kokkos tutorials where it's kind of just you pass it a path to the source code and it'll build everything it needs. So you can clone these and get into the Kokkos tutorials. And basically inside the example folder here, like this is the first example, it's just there's going to be a begin folder and a solution folder. And it's just going to be little problems like this. This is the first one. It's very simple. It just says include your Kokkos core header file. And then we need to initialize the runtime and open up a scope that's going to capture all of your Kokkos.
Did a GitHub link provides the implementation, right, for the Kokkos. The one
Yeah, so the top one, this is the actual library. This is kind of the source code you need for it. And then the tutorials is just the kind of examples. And there's a bunch of slide decks and a lot of information in there.
So when we go on Polaris, when we do compilation, we assume that the compilers already have support for Kokkos, or do we have to do anything?
And do we clone both of them on Polaris or
Yeah. Just if you want to follow along with me, you can clone them both on there. If you're like, if you have an application and you're trying to link in Polaris, there is a module already available. You can just module load it, and then the lib Kokkos should be in the path.
Then
But these examples are kind of designed to be integrated, where you kind of build it alongside your application. So if you have any issues with it, I'll show you like modules and everything to set up at the end. I mean, I end up using the GNU and a NVCC kind of things because they tend to be more tested. So you can go into like any of these examples and kind of start digging through to begin. There's going to be comments in there and exercises. This one's just, transform it to parallel force. Okay, convert the auto to parallel force. Which, should be pretty easy and mostly straightforward, but they're going to get progressively more challenging. This is important. And there's going to be a parallel reduce. And then you need to finalize the Kokkos runtime. So basically, kind of like MPI, where you're kind of initializing and then finalizing. Kokkos, you're going to be opening a scope and closing a scope, basically for main execution. So at least when I was running through it and testing it, I swapped the NVHPC programming environment for the GNU programming environment and then loaded NVHPC mixed. This just kind of works better with the existing make files that are in there. I didn't want to have to do too many modifications. I went into the second tutorial. I just went into solutions because I wanted to make sure everything was able to compile. You can just run with make and then your path to wherever you cloned Kokkos. And then there's these kind of two things that are going to get invoked. So there's Kokkos devices and Kokkos architecture. So on Polaris, you can set for CUDA and Ampere 80. The reason I went into the second one is because the first example isn't set up to run on the GPU. It doesn't allocate memory through Kokkos, so it will end up segfolding because it tries to access something on the GPU. Additionally, if you do kind of a newer build and you build Kokkos directly, you can build it using CMake, where it's going to kind of specify the architectures that you're building it for in that specific case. There's good documentation for that on our support center. Polaris under programming models. Kokkos, so this will show you basically how to load that Kokkos module if you want to use that directly. But also, if you are trying to build it, you can get some examples of how to kind of integrate it with your project using Make or CMake. And if you want to build it yourself, so this is how it was built on there, building 3.0. So it has support for OpenMP, serial, and CUDA backends. So basically, the library gets built. You're telling it what you want to be able to target, and then when you're kind of building your application, you can say what you actually want to run on. So if you're kind of interested and you want to work through it, be happy to help you. There's also Nevin. There are lots of people here that can help you along if you want to work through the examples, or if you have your specific code that you want to try porting like one of the kernels to. Work through that. Then I'm going to do something similar for Raja, where I'm going to give you some of the more kind of complicated examples. And then also get you started on the kind of tutorial that they set up. So a quick reminder on what Raja looks like. It's pretty similar, except we have this execution policy. It's an execution template, so it's for all policy type. That's your execution policy. That's how you specify what you're compiling for. And then the iteration space and the loop body, so the C++ lambda. So again, reductions are important. The support for reductions. They're a little bit different here because we're not specifying a reduction in our launch. Instead, we're declaring a reducible object. So the dot declaration is a reduce sum. That means add it up. It has a reduction policy and it's a double. So this reduction object requires a couple of different things: reduction policy, the value type, and the initial value. Basic things you should need for most reductions. And then you will just kind of access it the way you'd expect, plus equals or min max. The one of the things here is you can't really use it outside of the reduction operations. So I can't just like read some. And then at the end of the loop, you're able to get it out by using sum.get. That's like, give me the final result, consider the initial value, combine all your result from the parallel execution. So that reduce policy needs to kind of match up with the execution policy. They need to be compatible. So they're kind of exactly what you would expect. What I showed you before. So if you're on CUDA, you're going to need to do a CUDA reduce and then use a CUDA exec to do your kernel execution. The supported types are reduce sum, reduce min, max, along with max lock, min lock. And then I will mention that there is a new API coming in Raja in the next release. Is working on that ends up looking a little bit more like Kokkos, where it's passing in a reduction object to the kernel call. The reason for this is that it allows us to leverage things in the back end. So like with SYCL, I'm able to use the SYCL reduction because I know there's a reduction happening. Whereas with the current implementation, you have to kind of know there is a reduction possible and then set up for it and do it, but you don't really know which kernel you're doing things in. I want to go through the Raja segments, which is kind of what you pass in to say your iteration space. But with Raja, there's a few different things you can do. So you have your kind of standard one where you have beginning to end, 0 to end. But you can also do kind of strided accesses, which come up pretty regularly. And then you can also just do an arbitrary list of indexes. So you can just kind of say, this one, this one, this one, this one, right through. Then you can set up an index set, which can be a container that contains any arbitrary amount of these different kind of types. We do like a range and then a stride and then a list. You can also kind of, well, this is how you would declare a strided access. This is saying stride by 2, but you can do negative striding. So here we're going to go from n-1 down to 0, walking backwards. So this is why these kind of go up into a header file. The idea being that you might want to iterate differently depending on the device you're targeting. You don't want to have to change the actual kernel code because you're still iterating over the same space. You just kind of change the then there's the Raja kernel API. And this is kind of where you get some of the nice complicated features. So here it looks a lot like a for all. There's a Raja kernel. It takes a kernel policy, just like the for all takes an execution policy. But now we're getting a tuple that has multiple ranges in it. And then we have multiple iteration indexes. So very similar, except for now the execution policy is a set of policies that separate how to execute the kernel, and you have multiple iteration spaces. So the main thing is that for each one, each range, you're going to need to specify an index variable to access it. And then in your kernel policy, you're going to have an integer parameter that kind of applies to that tuple. So here, the 0 is indicating the column execution and 1 is indicating the row execution. So the reason we kind of go through all this is that it gives you a lot of this control and customization. So for example, if we want to interchange these loops, we don't have to touch our actual code, our source code or kernel code or the Raja part of it. We just need to change the kernel policy where now we're specifying the column be going before the row. So this is going to end up swapping your loops and it'll iterate in a different way. So that kernel policy kind of constructs a simple domain-specific language relying on that C++ standard support. Basically, you have statements and statement lists. So statements in action, saying like execute this loop, invoke this lambda, or synchronize threads. And then statement list is just kind of how you piece it all together. So here we're saying do an outer loop with execution policy 0. So that could be like do an outer loop with OpenMP threads, and then execute this lambda on the inside, and then do an inner loop with execution policy CUDA and offload it to the device. So all this being a way to kind of encapsulate your source code from how you actually want to implement and execute your. Okay, so if you want to kind of walk through the Raja examples online, you want to get clone this GitHub repo, Lawrence Livermore. Main thing is to include the recursive. So Raja is kind of built using BLT build. It's basically a way to manage submodules. So it's going to pull in about 5 different projects that all kind of live inside of Raja. And then you can go into this tutorial half day and take a look in there. So pretty similarly, it has these exercise comments, though it's kind of did the first one for you. So here we're just doing a for all execution using sequential execution. So this is the exact same as writing a C4. Then it leaves for you to kind of implement SIMD vector execution, which will end up being like this. And if you kind of notice, then we're doing OpenMP multi-threaded. The actual Raja code for all is the same. Always going to be the same. The difference thing is these execution policies. And then finally, you want to do it for CUDA. CUDA, the execution policy takes an additional template parameter to define your block size. This is why I mentioned why a lot of the Raja codes tend to be stencil codes, is because you can kind of control the size of your blocks, which can be important for maximizing your memory bandwidth. So here it's defining it just to use a 256 size block. Okay, so again, I'm going to swap over to the programming environment new, load to NVHPC mixed. And I also need to load CMake because we use that here, and we need a newer version than the default that's available. Then go into Raja, and you can make a build directory and go into it, and then invoke this CMake command. Basically, we're just telling it to use the GNU compilers, set the SM80, and then use this MVC GCC CMake configuration. Kind of the real thing you need here is the enable CUDA, and then enable examples, because that's going to build that code that we're just looking at. Then you'll be able to go in your build directory after you make, you'll have bin, and inside that's going to be your different executables. So you can kind of implement things, build them, and then test them out. Okay, that's kind of everything I wanted to go over. From here, we kind of want to take it more open, see what you guys want to do. If you want to work through some of them, or if you have like a specific problem that you're working on, you'd like some help with, we'd be happy to assist. If there's any questions.
So these are updated slides, right? Will you post them on the Slack?
Yeah. Coming from Fortran and then looking into integrating Kokkos, I want to introduce you to Tim.
Oh, that's
Coming
so
from a
neat.
project that did something very similar. Did the exact same thing.
Yeah, although, depending on the Fortran that you have, I think is duplicate what is done the project.
I'm new here for this on screen project, so I'm kind of getting more into the project, so I might maybe learn a little bit to understand how things are going. So especially like I'm not doing the build, I don't figure out the build on different machines. Somebody else is doing the build for us. So I want to build and then test on different machines, maybe on Aurora next, so I can test on CPU, GPU, some performance runs, and then also
I didn't quite catch what was the application?
HSM Scream, EMX.
Okay. So, yeah, because I mean, there are different sub projects in the E3. One of which is using,
Yeah, that's the one.
Simple is vendor provided.
Which they do rewrite for Fortran, C++. They do BTB verification.
yeah.
So it's correlation.
So
What we had done in
like a higher level abstraction, so like some other people, so you can run Kokkos that actually runs support backend. But then if you're on a device where the security support isn't very good,
Okay.
you could just say use the open for backend.
They're Fortran provide
So
data.
the idea is to kind of decouple you from that vendor support. that-
Especially here, we don't want to be locked into vendors. Every time there's a new supercomputer, it's likely a new vendor, which means you have to support stuff. If we have to wait for things like sickle, so that's time that.
Yep, they're very similar, they're both C++ template libraries.
Since then.
So from the user perspective.
Yeah.
Which I did not. Okay, so here's my one. Kokkos is, I'm gonna tell you what I have, keep doing a good job. So you're less hands-on. Raja is, I'm gonna tell you exactly what do it, and I'm gonna make it efficient.
Right.
Not as a.
Whether or not you believe that the performance can be realized without.
There's a lot of room.
It's whether you want to.
The testing or.
How much control and how easy you want.
Some small stuff.
That's even
Some
so.
of the code that they use because now they are getting into.
A lot easier.
You have the model and then let's say, hey, I
Details,
want to be able
simple,
to provide out the data.
Programming.
So there's some like small things.
If everything worked great.
That's part of it, and OpenMP is really designed for C, not C++. It's hard to, for instance, reductions, you can't, like in C++, a reduction,
Very
you would have an operator open close.
expert.
There's no way to tell OpenMP to
I
use
want to be
that.
like understanding this.
Actually, that might be coming, because
Around small.
we're pushing for that.
Compilations.
Yeah.
But it's really about marking statements.
We had a
C++.
special
you
yesterday,
want to be able to mark
there is an LTRD
expressions.
project. We also want to use like different HSM models to kind of discuss.
You change the process
There's
in many Kokkos.
a variety of these models.
Hopefully, you just compile the code for your target, everything runs great.
Yeah, some
The question is, if it's not really running as good as you expect, then you kind of interface with your
Physics
Kokkos team.
so
It's
kind of mix and match.
I don't know what.
Something simple like this to play out.
Yeah.
Change the iteration. It's not that simple. But yeah.
Whereas in project, it's not running perfectly. It's running
That's the one most
specific,
production ones.
but then whenever you go to a new spot, you have to tell how to run specifically. You don't get the same try.
So how many people?
But I wanna be familiar, like, install this stuff.
So here's ALCF, we have quite a bit for
Test
Kokkos
those
projects.
CPUs.
Currently.
He does those things, but I
They're
wanna
called
go
kind of
small.
widely used.
Benchmarks.
So just to,
So it's-
one context here is Kokkos' version.
They do very large scale runs.
Kokkos is in version
4.2.
4.2. Raja is about to use one. So it's a bit similar, but all of Lawrence Livermore uses Raja.
We can do it with
Sandia uses Kokkos, that's where they kind of started.
This
And it's
HSM
picked up
RRM,
in
the
some
region
other
requirements,
places.
snapshots,
I could grow.
also on the ways to probably we have to also machine benchmarks besides. So see around one day how long it's gonna take.
I work on code.
20 to 40 simulations. See and we get this. There, like there is that those types of things. So the Scream itself does not so many models as implementation. Doesn't really fully cover. So
It does have a GPU.
yes, but yeah. Yes, that's I for atmospheric GPU, but it doesn't do the fully coupled. Other components only like static. So E3SM try to implement as fully coupled. We are interested in doing fully coupled simulation atmosphere and the oceans interact with each other. Then there is no GPU implementation.
What's the state of ocean?
I'm not sure. Usually there is one A3SM, I know the CPU has called RRM. Arborex had, so we want to test and all our CPUs. We're just linking to see Arborex. That's great. I think feasible.
Yeah.
We will just play around and get to like it's kind of good at stage. So what's the type of create mesh? I think the or init data.
So it's very similar. There's the difference is there's more GPUs on it. I think it's another couple of months instead of one.
That makes it a long way to 17.
If it's an older
CPU,
CPU,
was 2 years. Was maybe more time.
Because I'm
Aurora
was
one thing should say.
If you're going to say
runs on Aurora,
it should work well. GPUs.
Yeah.
There's all kind of gotchas.
find the old.
Yeah.
We are exploring the space.
Yeah, I mean,
the worst case, I
with respect to running smaller problems,
think that the issue is just to check out X and.
the only caveat is that
But Kokkos run, in particular, I remember you
cannot
can take back
start
compatibility.
that's not.
Doesn't mean we won't break it, but we try really hard not to.
You're not gonna get efficiency from. the GPU.
Yeah, well, we tested like.
So you want us to compile the Kokkos or just load the module for just exercise?
For the exercises, do not,
By testing.
just go into the tutorials and then
Run it?
pass that Kokkos path, and it's gonna build the parts of Kokkos that it needs automatically.
Okay,
That's
but
what
I looked into the makefile for this tutorial, so there is already a Kokkos path and it is like to a different.
Yeah, that's the.
There's one that just kind of checked in.
Yeah, that's the
Doesn't
one
really
that's.
count.
If you check it yours out into that same location, it'll all just work. Otherwise,
Right?
so if you clone and you make a directory Kokkos and then clone it there.
Yeah.
Then you don't need to pass the Kokkos back.
Yeah.
Working on small.
It's set up for Volta 70, which is for like the
I mean, chances are if you're.
8100, that's just like optimizing for the GPU kind of things. That's why there was an Ampere 80.
Okay.
So we're running a newer GPU, but I don't think it actually
Yes.
full pilot for a lower compute capability.
So that again, go on the players. And then let's get that, use that Sunday night. CP kind of first. And then
Answer, yes. And can you get by CPU?
But like, I'm gonna show, maybe at least try it one. That's at an A.
Yeah,
Quite work.
I was playing with the modules, that's why.
Yeah, yeah. You know, I think
There's all other stuff from the programming environment.
getting time on the system, right?
HPC, because that's gonna be like GCC, G++ using MVCC, which is probably what you're using on the GPU.
That
Compared to the default environment, which is
like
like
a target, yes.
the newer compilers.
Not inside. You don't use GPU, and there's not much.
Yeah, I mean, ALCF, I mean, if the program wants to sit behind it enough, you could conceivably get it.
CPUs. How about Aurora CPUs?
It's the same story. When I load, and then the Aurora CPUs are actually quite solid.
Right, so I want to tell you, only NCP access to NCP.
Yeah, that's a maybe a bit uncomfortable question right now.
Largely not.
When that happens.
Mixed means new and.
I've been waiting.
So,
Yeah.
the HPC mixed is like kind of saying, like, give me access to like CUDA, like the CUDA libraries, those kind of things. But I don't want to like,
It's
the rappers
available
to
on-
use MVC, C++. I want them to use
Doesn't have to be
GCC, G++. But I still want to use.
I think that
CUDA,
E3SM
things like that.
Yeah,
So like that's kind of how it was set up.
through that, if you're
Pretty
working
long
now,
time.
you should.
I'm not part of that project.
GCC for your other files.
I feel that
He's on that.
I would like to be able to do this, because sometimes there's also. This other stuff, so Also, it's just a trigger
Most of our code doesn't use to do.
which is basically we are.
Yeah.
It's-
And,
Yep.
right now, the only option outside of the sunspot.
So what we started with, okay, let's try this part. And lab.
They have some.
All of it, but anyway, what is the higher parameters over the CPU?
Yes.
Same,
First, that's.
same kind of
So,
GPUs.
RLM and CDF, NetCDF, GPF5 GPUs, they are mostly related to IO.
Yeah.
Because we have to read files, finance.
You can get an account. Well, you can get.
So
They
I
have
understand why
The way they set it up,
shouldn't have much.
they're trying to sell time
Yeah.
on this thing, but you can.
I'm surprised
Good
when
one,
I,
you can get.
oh, that's enough. When I switched, I said, okay, let's do the GPU environment, then this becomes incompatible.
If you're interested in that, I can send you.
So.
It's for the LDR, just I work as well, mainly, we want to I don't know, like, for practically, by give you access to the machine.
Aurora access won't come for anybody outside of ECP and ESP. Sometime next.
XPO has to change.
Yeah.
That's what I feel like when browser is, oh, we'll get access in something.
I didn't know about that.
Programming.
Yeah,
Little
and
TRG.
as I said, I think it would be helpful if LCF had some public facing hardware.
So swap that for that same thing, just dash GNU instead of just.
They're trying to decide whether they're going to try to buy to filter like these things on the platform. If they do the latter,
So now.
they may be able to arrange it so that it's.
So how's the experience with these guys, these
So
CPU
they are
projects?
still
They-
Yes,
running
just
on
refresh it
Breakout?
to make sure.
What I see from this issue, like,
So like.
I can run the code, but not performance, so it's something we can use.
Yeah, I mean, for the most part,
I'm surprised if you have an
people are
issue.
happy that the most mature projects. I
Before
think,
I
generally
load
found
the new
performance
flow
that,
and
you know.
Yeah.
Yeah.
You got like swap.
I mean, all modules are.
So you
that
you
by
run
variable
on
that
Polaris.
so
You can run on, yeah, if you compare to
they're not
this
perfect.
code I've been working with.
It's largely for those.
Polaris and Homerding and Frontier.
So you don't change, you just change.
Yeah, we use Kokkos.
It runs as is, right? So you got it.
Yeah.
Yeah, we don't change, we don't have any machine specific code at all.
That's,
It uses
I don't know
Kokkos.
what's wrong with this. I don't know what's wrong with this previous script.
Oh, well, I mean, it takes some,
Guard
you
this
know, it takes
running
some
already.
Yeah, so it'll probably.
So you still need our machines.
Okay, first you'll need to get on a compute node.
for us as Kokkos users, that mostly just takes the form of
QSub.
building.
Sorry, what they call it?
It's a QSUB.
Oh, QSub. Okay.
Some other projects
Big I.
directly.
It's interact mode, dash L.
They have select tuning of that single code.
I get it in the class, but I kind of. Dash A.
But in any case.
Should I put it down?
Whatever.
I don't, I should have it over.
Yeah, I think it's in the
Level of
Slack.
security that was supposed to.
On the
and the Q and A.
Here, runs faster than it does a 100 NVIDIA GPUs, which are slightly older.
Yeah, if you go into QA and scroll up a little bit, you'll see posted.
I couldn't get away this morning.
This will put you on a compute node where you have the GPUs.
Some, a lot of the emphasis. The machine came on first and they brought under pressure to show their demonstration.
They show good numbers for entry itself. All the way to the machine.
Yeah.
Like practically, can you get that whole machine? It's just gonna get most 1 iterates out of 8,000 months.
It's the main difference in performance. you'll
Yeah,
get is when you use the GPU.
So just.
So Kokkos and Raj are one way. they use
You know,
the
through
GPU.
the
You can also
Insight
use
program
SQL
and
or
the ALCC program.
But if you just have
Sort
like
of
C or C++
With Insight,
or
you're
Fortran
expected
code,
to
you're
use
only
at
going
least
to be
20%
using
to have
CPU, which just has the one bandwidth and the flops and everything, so.
20%
Yeah, I see on Polaris
It's gonna get
sometimes.
you the most performance.
For
That being said,
said,
you have to move whatever memory you're using over there and watch it.
It's, yeah, like the project I'm working with, they use more than 60% of the machine for single runs.
Logs the machines on Polaris and because they also have pretty good priority, right? Larger jobs and then so my small jobs.
That's right.
That's
That's right.
So
Yeah,
the goal
LCF is
is
not
for it to
friendly.
be the same.
Small.
Because
For that reason, I
you
tried
can
to
take
bundle.
your Kokkos Raja and run it out.
You run on
something
GPU,
else.
your core code, you on Polaris.
Reality
The
jobs
jobs
is
10 to
10%.
watt nodes. They are nicely bundled together. For
Sometimes
example,
we
120
use as well.
Yeah, if you're doing ensembles, that's.
They're just like C++ templates and it just lowers down to
Many
CUDA
projects do that.
and then actually calls
You
CUDA.
know, generally, when
So
you're
the goal is for it
running
to
an
kind of be
ensemble,
general
you've got all
way.
your issues sorted out and you're ready to
CUDA.
do the scientific runs.
If you code for CUDA, then
you're not doing
it's
that.
not CUDA based, you have to.
Yeah,
have
one thing I noticed,
Like there's,
we do this
so
like
like
1 year in some.
Raja will give you some tuning parameters, but there's nothing that's available that you can use
Conditions.
in CUDA.
Once
It's using CUDA
So
itself.
finish the simulation.
If you're a Ninja programmer with CUDA, where you're
Produce
doing
about
like work synchronization and things like that,
Sets.
you can
Those
use
are the same way.
you can use that.
Ideal,
inside
so
the
that
Raja kernel,
the
but
reason
you
was
can't
to
use the
go past
capabilities.
100 mod
So in a nutshell, if I'm
queue,
already
so you
using
can submit to
CUDA
large
dashboard,
queue.
For CUDA on Polaris,
You have 3 hour, 6 hour.
you
and
probably
24
are, I mean,
I
obviously.
see what's different
probably
before, but they
optimized,
changed
but
it.
you could optimize the CUDA version.
So 1 month
It's
finish it.
just
10
kind of a
hours or
portability.
I need to, if you go to large
Here,
queue, otherwise I deal with 3
yeah.
stars.
They're running AMD machine.
Finish it.
According to CUDA, they have next to matching, but if you're on Aurora.
Every
you're
month,
not
one of the
CUDA,
number
you have
phase.
to-
Or
So
some
these try to
GPU
set up
error. It's
Basically,
like
the
goes
philosophy
to
for Kokkos
some bad
and
Raja
Raja
or
is
something.
that
It always the case, so
the vendor
I
is
cannot
gonna
automate
want to
for
use a
that.
specific
Normally,
language.
I feel
They're gonna provide the best.
I should
solution
be
for that
start
language.
the.
So we're just gonna
set
lower to that,
from
which we don't wanna try to
first
make them
ones.
support our
And then
language. because
Chain them with dependency jobs.
You don't want to be.
Wait for the finish previous,
Yes.
wait for the previous, so that just the
a
link,
lot more
correct
yeah.
restart files for previous simulation, but almost all the time,
But yeah.
one of them, after maybe another, one or 2 months, fails, so this is good, and it gives me headache, just, I have to read something, finish. To.
Got it over here.
Numbers,
So now next step.
Yeah,
There's
tutorials, there's always a baseline hardware failure rate for these virtual machines, and I think the human Polaris is big enough to, that becomes visible.
So
But
even
the
like
really big machines like
Okay. Go ahead, run. The reason being that the first example doesn't have
we were right.
the first example doesn't
Each
use
kind
CUDA.
of on.
Kokkos, whatchamacallits. Kokkos views, so you don't allocate to Kokkos. Kokkos doesn't know how to put the memory. in the GPU. The first example, all the rest of them have it.
Okay,
sure.
sure.
You can
So I
compile
just
this
put the same thing for the second one.
Yeah, the second one should work perfectly. The first one,
It should
if
all
you
be
change the Kokkos, whatever says to CUDA to OpenMP, it'll work. It'll just run on the
very
series.
unusual.
Okay, sure, fair enough. But the second example. Next it on.
So shall I remove Q Del actually?
You can sit, no, so, from here, if you want to leave your compute node, it would be exit, but you don't,
You
I
don't have
mean,
to
you can
leave.
work on it.
Yeah,
right now.
it's your node, you can do what you want with it.
Next time.
You
You
have
want
your
it, you
node
can.
with the one AMD CPU and the 4G.
Okay, hard to submit the ticket.
And if you're gonna leave it.
Yeah,
No, so now I will be going for the second example, just to try it out, just to run something,
Yeah,
right?
I mean,
Then again, I'll get the node added, so.
You can compile straight here on the node right now.
Yep.
And not have to like.
right, I mean,
Plug it back. Some
and if I'm doing development, I normally sit on the node, if it's a longer compile, I'll have another window.
Yeah.
That's
Understood.
sitting on something that gives you better, faster compile. But
It's really just, as long as you cloned everything, it's fine, because cloning from the compute nodes
Manually.
doesn't work, or it
Right,
has to go
is-
through proxies. or
Right, the
something.
compute nodes are not on, you
Find the
know,
one fails, and usually when
Right.
I use the older
Oh,
size.
yeah, it'll compile. And like, there's a lot of projects where they like check what GPUs they have, so you have to.
One dies. that's-
So we might, I think
I think we got rid of
we might have
most
just added some GPUs to the 11 nodes.
8 to 9 hours, 10 hours. But then this thing, I'm just earlier dies.
no, I was trying to zoom in before I left, but.
Then you're on the small
Yeah.
issues. These are the solutions are there, but it's just.
The other approach is to use, use a more.
So.
It's involves some of the stuff, right? So I saw like, I saw those.
I know there's, used to be there were no.
More
GPUs,
work, more less work, I cannot.
Because they added some, just to simplify compiling. So basically,
Yeah,
you're pointing out like, you're like doing that. So that was probably.
Yeah, someone's gonna notice it.
Grant
and
years.
curious.
You should be able to submit one, but it's never the case, always, the machine is not. The node is not. Something down, like, it's not practical, technically.
You don't have the same.
Yeah, well, there, I mean, there are other people who are much more expert with 7
That says that when you're looking for library, some are not give you on the.
more
Yeah,
beans.
we tried-
these could be the same.
If they're not, let us know.
So in general, they are.
Yeah, you should be able to
Yeah.
access everything.
That wasn't always true, but we're trying to get better at that.
So when you.
People also can.
It won't inherit your environment, so you'll have to have like models to your.
Job returns and other things.
Not use the login node because.
If it ended.
Compile on interactive node where I have full, it's much faster
Right.
because of the libraries. Can I do the same issue? Allocating one node is not.
Many simulation.
It's been cases where they're doing, search spaces.
Not too far away, but we should.
It may be slower.
Right.
It would be slower than
It's,
login.
it's something that kind of.
It can be, I don't have to, that's not clearance.
You've got a lot of runs and you want to be able to request a certain amount of resources and then.
Not for it.
So you don't have all kind
Well,
of.
it's exactly, there is no internet. out
There
there.
is no internet, you cannot do.
Right.
Running.
Yeah.
So is it more local or can it spread to the different machines?
To my knowledge, it's within a specific machine.
So ALCF and
Well, I mean, also, I think it's been run on a platform.
Right, you have to go to that machine and you have to have your data. So, right, because it doesn't handle the data transfers and stuff.
To my knowledge.
I could see that. I think something
that's using data.
more recent things that are being tested.
Data.
You have particular data dependencies to see that should
We're like testing the next.
this
But it
is.
won't be the default units. You could find things like that, but.
There are always complications.
Yeah, yeah.
Don't have some.
Principle of the job scheduler that LCF has now understands
Because we have like
the
make check,
concept of the different
make check.
platforms, so that you
For all code, it's just.
everything at least is matured.
When we do.
The band,
But those.
machine boundaries are for. I'm not aware.
So that is.
I mean, ideally. I know like that type of solution would be the best. But I think simulations are requires. Previous simulations, so there is like two baselines.
Yeah,
For
exactly.
20 years, either you are continuous.
Is the only thing, but that's
All
what
the
it
next
requires.
month or next day depends on the result of the previous days, like previous station give us this.
It should just.
Around
I'll tell you,
20
if I should concur, that's something like that.
Need to separate wires. It's honest issue, people don't have. I prefer that, so I can.
But the reason
And some of them
faster,
each year is a new
a lot more
units.
CPUs.
Right.
I don't compare usage of so on, like 1999, and so on to.
I built,
But right now,
I built Kokkos.
just wait for previous. So always there is this like hard data dependency, and then you can only accelerate so fast, even with the GPUs. Then like with the GPUs.
So
three,
when I
4 months.
recompiled, it started, I just did the maintenance, I was on the student node only, and then it didn't find the, it was looking for open amplifiers.
Right now.
So now I'm gonna include the finished Kokka device, I think.
Yep, yeah, yeah.
So I skipped the Kokkos part since I have that thing, and I'm already on the node. So I'm gonna skip the last one as well.
We have not solved.
It might not, so I don't think it's smart enough for like,
optimization.
but it's a
Maybe like
kind of thing.
management system.
Okay, so I thought because this is the one that gonna allocate the compute node, no?
Right now,
No,
it's for CPU.
so you're already approximately, you know, you have it. Kokkos, the Kokkos library just doesn't check, hey, what am I on?
Oh, okay,
So
okay.
I don't know how much tile it
Okay,
counts.
okay, okay.
Yeah.
Okay. I just didn't want to go like, nested kind of thing, so that's why I avoided.
So it does somewhat check. but it's not-
With
it's not-
CMake, I think it
Yeah, with
might-
CMake it'll check.
CMake it'll check.
Yeah, and we're moving, certainly CMake is now preferred.
Can I do -J on this one?
You can, I'm not really doing it, so I don't know how much you
How
have
many
to build in
CPUs?
parallel. But, yeah, you're on the compute nodes, you can do dash J.
Oh, yeah.
Per core,
64.
It's what I accidentally do on the login node.
each core writes its.
It's always an accident, I don't ever read it.
I think you're only building like.
Tedious.
Right,
Like you're on the compute node, it's all by yourself.
Yeah.
So you can use 64 cores to build. Generally, I was told this, I have no idea.
Oh, you're doing all the Kokkos, yeah.
Use all of the actual cores.
Yeah,
on your
it was only
32
two.
threads.
This was even back.
Plus one.
Yeah.
That's what somebody told me is the most optimal number. is eight.
Parallel, this is like-
To fire off, I have no idea. why
I
that's
forget,
true.
yeah, I looked at the Ninja build, Peter Ninja Dash, like, it's supposed to like
It should be as fast as.
Like, This is
maximize
this is the good number.
And for a while they had
How many?
2 times the number of cores plus 2. It's really more, right, it's a guess, right? It's when this thing is stalling on IO, you want something else to go in there
Yeah.
and do work, right? So optimizing that's really hard.
It's the case, so.
And like Clang and GCC have 2 very different profiles on how they do like compilation.
I get very good speed.
And they need to do IO and stuff, so it's.
Still not as fast as writing per core.
Yeah.
So ran on CUDA, you can do NCU,
Pretty good, but the
and
question
then
is,
the name of your execution. So if you had NCU to the.
I
bottom,
overload the machine.
dot
So I'm
slash.
gonna run
Okay.
5
Um,
sets of simulation.
NCU in the front.
Provide
So this is the
I get it.
NVIDIA compute.
data
something.
every.
Like this? Oh, the profile.
Yeah, so it just like, I always want to sanity check that I'm like, okay, it's CUDA and it ran.
Simulation.
Use the GPU. So here you can see it's,
That,
these are all,
that should be
it's only gonna do
fine,
this if
because
there's some
the-
actual CUDA calls being done.
The aggregate.
I actually wanted to
You-
see,
you can
like, the same program running on the CPU and GPU. Can I do with the, like, slight modification in this 0 to 10, or can I? do
I tried
like,
on
on
opening
OpenMP versus CUDA?
Yeah, you can build this with OpenMP. If you try to build
Yeah,
with
no,
both,
there's that.
this is both
the
libraries
Lustre
and.
File systems.
Bug it, you should be able to do it.
Yeah.
But
Okay,
yeah,
so
you can build it
even with
for
that
each one right now.
516, 80.
If you build both, that's possible.
Yeah.
Or maybe I
Yeah,
just
I
need
gotta
a
do
different
both.
compute nodes, right? I can have 2 different
No.
compute nodes, and then I will have different libraries loaded in both of those nodes, and then I can.
The system is supposed to be
If you,
designed
yeah, you could,
to allow.
I mean, that'd be doing like 2 different applications.
Right, 2 different in the same application.
It's supposed
Yeah,
to-
usually MPI is running like 2 in the same application where they talk to each other. So
What's the
Work on this, I'm working on this, only talk when you need to.
Okay, well.
I've heard
Rutger-
that Kokkos
Rutger
feature
has,
requests would support more than one at the
follows
same
them
time.
through
Yeah,
the
I mean,
number of
there's, you know,
servers.
there's applications where.
And I
people
can't
might
remember
use
how many
any
servers they
servers. A lot of like the exascale projects, a lot of these are like integrating 2 physics modules. So you're like
So that,
doing
that's where
this
they
kind of
get it.
simulation.
that's how you can get an aggregate.
CFD and combining that with
Hundreds of
actual
gigabytes, terabytes.
active simulation. So it's- It's like,
I'm preparing to some.
people are doing it, but it's not. kind of
Five
our
paper.
bread and butter. Thank you.
And the opinion CDF helps us to ready. The end of the simulation for the months previously, we had the, now it's 24.
And then more work. So it's about 36.
You're right.
You chair the library. It was intelligent.
Yeah,
Now,
actually,
actually,
Starcy Pecan
At
just
some
got back,
point, within a single directory.
but doesn't know that she can get back out.
Files large on Lustre, it falls over. The
right,
performance falls
it's just
over
like
again.
stock.
Yeah.
She got the slack, she can't get. She can actually make it out there.
Address some of those kinds of. issues.
Well, the other thing with the data, like compression, like ideally there's NCD version, NCD4 has slow compression with slow. If you do inline compression before you run data, it falls back like a single core. It does not do like a parallel compression. Yeah, so is NCD support for that?
I don't know.
Yeah, so that's like you can write smaller data, but then you have a time limit quite significant for a couple minutes per file. So we may do that because sometimes we keep hitting the storage limits at 66 petabyte, but not the as for petabytes. And you'll need a couple.
Last week I had like the safety panel, like I got thrust in
Offline.
at someone like Bjarna on stage. When we were testing safety and security and C++.
Oh.
You really do get roped into things. Hey, we want to do this? Sure.
Some people at Argonne have done work on. So sort of. More.
How this morning go?
Compression.
Good, I think. I'll go with that a little fast. Go whenever I forgot to take my walk around.
So, and some of those.
Yeah, like
some people
we
have
did
used
a
those.
3-person talk last weekend, like silly guys and safety and security. On stage. So that was the middle ones, like, oh, no.
Next thing mostly and that Colleen experiment is 6.
Yeah, I saw it.
Distortion. Anything meaningful in the statistics 4x.
Probably could be there more, but you could get lunch.
I was just going for dessert. Anything else you want?
No.
I mean, they have extras.
You know, like rather like
I'm not gonna be able to
I
make
mean, just save the restarts and reruns almost faster. We are on GPUs faster.
They will be after their physical therapy. But they not going to. I mean, it's supposed
Some
to
projects have
here.
done things like
It would be free, but it's not worth it.
floating.
That tri-state drive is just, I hate that thing. That's why, it's the main reason I don't want to come in very often. I just hate that drive.
Yeah, that's, I like, I'm an early bird, so I gotta be out of the house before 6:30, so I hit zero traffic.
Certain fields,
I'm in
certain fields
right now, it's not as far,
Yeah, I used to live in Lakeview. So
not as far, but,
Yeah.
yeah, definitely after 7, it's like, okay, maybe I'll just wait till 9.
Sometimes they use the.
Well, next year, Wisconsin's gonna be in the city. Figure out how to get our guys to,
That's
because it's gonna be still gonna be under construction. I can't
They-
get downtown.
Yeah, my
in 2 hours.
understanding is that's the way they do it. So GPUs have these reduced floating point times intrinsic.
So
you
it's-
just- you just copy it.
it was a much faster, right?
Yeah, you copy it in memory and then. Get that back out with that output.
Well, I want to try this ideas to thanks to these guys do this emulation of some of the complex physics options to speed up. And it's in a way they are kind of similar, like using reduced precision. Questions?
Why do you start using? Yeah. Right now.
Checksum. Like, correct. Error checking information.
Data is something not sure.
Writing out that much data. It's a good practice. Something that are writing petabytes and petabytes of data, several family. Errors that happen in the course of
It's
person
writing,
writing to the disk or whatever, and
when it's getting more than 100. Sitting there and just
it's, I don't know that the causes are all understood well. They've taken to writing out. There's a chance.
I would say I should now be more than.
We had cases that we need to access, especially the restart files. We have to rerun some of the cases. But beyond that, like there is this like outputs.
I mean, we're getting better at documentation.
Yeah,
but
this
that's-
feels, you know, data that.
We still don't document it, so it's still very well.
It's less critical, it's just something more on top.
We need to sit like and do that like judgment, just to like take simple approach, save everything, and let's figure out later. But then too much data, so I don't know.
I want
It was
to,
interest from
production guy, okay, here's the black hat, so now it's
this should be
you
done.
mentioned like
Project is
Oh, wait.
how to active.
every backend specialist, there's no one that uses this actual, so.
Abstract.
Why, it's not abstract, like there's implementation there that no one uses. You want to learn about deduction guides, use that. It's very interesting.
And lots of
Listen, what's our foundation?
not enough time.
So if you have three things, great, it's not fragile, right? Because now, because normally we do.
I know, something like complex.
And,
You have to do triage.
that's a primary template, I know what it is.
Which the
That's the door check.
thing.
Well, that's fine. So
It's not our own. Are these used?
I like this.
You want to get rid of the breaks in this other part.
Be more word burden. It's not so data. It's kind of difficult.
Is there any specific OpenMP module
I
I
like
could
all
load
these, yeah.
or just module load OpenMP and should be fine?
This one.
Like, I did this, we did this for the CUDA, right? Now I
Yeah.
want to repeat the same for the OpenMP and just compare the numbers.
So you can just do Kokkos devices.
Oh, I don't need to load it.
No. So basically that's because right now, if you did the modules I did, you're using like GNU GCC, which have support for OpenMP on the.
Oh,
host.
okay, okay.
And
that
then
is-
VCC, which has support. So like the keynote this morning, like their application, they like spawn off threads on the CPU. So you're using like 16 different CPUs and each one of them is submitting to the GPUs. So they have to use like OpenMP, CUDA. So,
Okay,
you
okay.
know,
So is there any, like, should I put a camel case, anything like that?
camel case works. I'm not sure if it has to be, but I know that.
The other thing is.
Or big O, big MC, I know it works, but I'm not
Okay.
sure if it matters.
How cool with models.
I think in Kokkos, if you set the CMake options, we check.
Architecture, you know the flag for the architecture for AMD.
It's still
on.
You can also certain things. Sorry. It's gonna take probably.
Because that passes like 5 years.
Right.
Flags,
To see that.
there should be more,
in
but I
everywhere.
don't know, I know. it
Like
can't.
CPU.
As for case, I think we check now and we'll tell you if the case is wrong and you're like, CMake stuff.
I can get it.
I should have.
Yeah.
Come on.
Post, it's better plan than.
Right there.
So that makes sense.
Kokkos, et cetera.
Okay. Like it because C++, would be everything easier.
It's slower on the GPU, but it's so fast. So the
What
GPU, you have
load
to like
is-
send it.
Workload is not sufficient.
So what was the reason for like instead of
Okay, it's faster to just do it than it is to just say, hey, GPU, I want you to do something.
Yeah. So there's open and Peters.
There, if you look at the source code, there might be options that control like the size.
It's, I mean, it was a.
Just
It
random
was, it was, you know, all of these were.
Give it a bigger problem size to play with.
I think we had. There's a little bit of territorialism behind it, right? Like Raja came, I believe, primarily out of Mars Livermore National Lab. And they have their set of long-lived applications, a lot of development. They wanted to have.
Did you get a move for this?
Some ownership, portability.
That's-
there.
I bug Kevin on last Wednesday, he had like, the hotel cut off this Friday. So-
Oh,
Well, that's
yeah.
Friday. It's like-
Right, and but I do think that.
These are back-to-back trips. like,
I would-
really good from Hawaii, that I can't pack that.
Oh.
I learned
Like,
how to
actually,
do all this.
like, the other one.
So last time I threw from Denver to Dallas. The 70s.
I was,
It's the deal. I'm in shorts and a t-shirt because I'm like 85-degree, like Copenhagen, so. And the hotel room to change it. That's why I remember last year I had only had Hawaiian shirts since I had. There are no, I don't think there are any attached. I got whatever was the very first box. I'm like, oh, I'm the closest. So by the way, there's a lot of these. CP was in Denver last week. There's a lot of instructions.
Can either be something you pick up off the shelf like Kokkos, or it can be something that you develop yourself that's domain specific. Generous. The developers on that, I think, or that it supports.
So there's still some that.
Leaders experiments. Evan, do you know what about the Python?
Yeah, really real work. You want the truth will
They're
answer.
like being explored right now.
Yes.
There's definitely no like real support. It's something that's
Right. I mean, we definitely want to do it.
Part of ECP, if you look at,
We need to find people who are both Python experts and
you know, like the
C++ experts.
AMR EX library, right?
And that work at the national level. you know.
It's sort of a general purpose.
Finding that
library,
person.
patch-based AMR.
Yeah, so I think they use.
Yeah, I struggle with Python. I can get it working. It's probably not great Python.
Yes, so it's used by almost all projects and.
And there is that portability.
There's like, I know we've been discussing.
That library.
Yeah, the, you know, it gives you abstractions for, you know, defining and managing the patches and for dispatching work.
Right now, there's two.
Covers a lot of
I don't
ground.
know. I'm sorry.
You know, finding different base solvers that are like C, C++.
So that was one of our target models.
I don't know, it's.
A long time ago, there wasn't loose Python. Plus about it. And old,
I think,
possibly like, but I don't know.
I'm not, but I think I'm optimistic.
No, they're good questions. Yeah, we definitely,
There's a
definitely
relatively small
definitely
number
want support.
now. part of what it is.
So it's more borrowed, it's Python.
Yeah.
Yeah.
And bring up those questions tomorrow.
One sensitive thing, I don't know, but it doesn't really matter. Number of.
Well, no, but it's, by asking the question, it gives feedback hopefully to the right, where the right people. will get.
Not wide, just not.
I feel like these.
Our machine.
So we can.
The immediate, that's,
not do that.
that's where I started. And then I got
They do, but
requested
like, you know, Python's got a huge number of libraries. I want to graph something, I don't
We'll go
want to.
diverse.
Right,
After
yeah.
position. Then
Yeah.
it creates all kinds.
So those, that's why I want the integration, right? Because there's a lot of strengths. that
It
like
does, and that makes it
Take
even more
advantage of
important.
Right.
know, build equipment.
Strategy. And, Intel thinks they call themselves. You can run it on. I consider it to be both. It's like yeah, the same level of abstraction.
Well, I think this thing is within capital books. So you just create something small like a. Even when you. Yeah.
I'll figure it out. I can find it.
The idea of how long it takes.
I'm at third floor somewhere. I
I
don't know, they haven't me because either me nor my office mate comes in.
I think compilers can have.
You don't need. That is only.
They said that.
Yeah.
Yeah.
Yeah, then I have to go point out again, it's not average usage, it's peak usage.
What's your goal? You have to have.
We all have to be in, we have no off
Tolerance
tolerance, it's
for-
just data, which was aren't doing work.
Accepting.
As you can see, I got my badge, but not one as well as.
Those, they last like 12 months, right? You're gonna.
We have to.
Not change, yeah.
Someone put my board. No, wait a minute.
But those 10% add up. You add up,
2.5 year process.
they add up, but
It was
it's
dark.
still.
I got fingerprint. Fingerprints, and they're like, yeah, it's just.
Well, the problem is like occasionally hotels want to see that.
Yeah.
And I'm not supposed to show them this.
It's not supposed to show.
So I should. And I found out clear plus on the deal. It's going to discount. Employee discounts, it's $99 a year. Oh, 'cause since I flew out on September 30th.
I guess that is not still like.
What's gonna happen? It's like, okay, a lot of regulation, it's not run by the government. It's flying, it's not by the government. It's a pure win. So, yeah.
It's closer.
And I don't know, and I didn't, just gotta show your ID and have a .gov email.
That was we were
Clearly to use. And I was gonna turn off auto review, but it said, oh, no, auto review you did. So I never have to print this again. Oh, there's.
Not something that's out there.
Circles, constructs.
Really good at the line.
No.
It's yes,
Other is just interest.
but it was still 15 minutes away.
Not in Friday. Not like rewriting the whole application.
I mean,
Yeah, I wanna go to the compiler with Alice. So I'm gonna go back Saturday. And just want to express.
Users, it's very important for schools. Takes the board.
That's how I want to do this. See what's supposed to be. I don't know. It's a lot.
That's important. Let's you might change it back. Who's almost to the width of the file. Because these models are evolving in 10 different directions, and then you bring another dimension change. Developing important.
So I need to travel to Cruise so they can book the flight. So they book the flights.
Yeah.
I did Israel and Bulgaria this summer. This one, of course, it was busted. So it's really.
Semantics.
They did not approve my flight, sorry, did not approve my trip until 12 hours.
Tell me one thing.
Different.
Yeah, we do this, it's a meeting. If I really could do it. So we be bringing it.
Okay, so now,
So it needs to be restructured.
Six months. 6 months.
Yeah, I have it on my calendar to renew it like 364 days before.
Is a mindset. Like this.
Yeah, I had to do like this. It's out, call this number and try to get it. For sure. It wasn't too bad though, honestly. So I'm in Chicago, so it wasn't hard to get.
It was the old days, like I was at Apple and someone needed a passport. They called the senator. You know. Because there was no expedited, they just called the senator and have it. It's like, really? That's how, yes, that's how corporations work in the world. Have improved my travel, that's.
like, so we can now run the post and see the different aggregates problems.
That is one of my fears, like, I think. Yeah, if it Zoom, like background, then you have to do it. It's even messy up.
This.
Compiler.
So this I this allow this also loads CMake. And then I this is my command to build Kokkos. This is just Kokkos.
Oh, it's HPCs.
So it's using this. Do I have to specify over here?
It's two older versions.
Yeah.
Wants to do a version of the HPC. So for the MVHPC next, there should be several versions. Try one of the newer ones. I think the default is just for Kokkos.
So I specify in the
And the module below the module.
Yeah, like module. MVHPC next, whatever version you have for a newer version. Yeah, because it's saying that you're using like 21 point something, it's 2 point something.
Yeah.
I don't know why.
Kokkos
Kokkos requires
no,
some
because-
brand new.
That's it, but it's because we're those were. So we need at least decent support for 17.
The other thing being, so.
And we're the choice support.
What was your CMake command? Wondering why it's using MVHPC.
I didn't specify them. This
So the module's finding it, it's just finding first on the path.
so NVHCC.
But both modules will still be.
is much higher. And
MVHPCs. Slash BGI. Sorry.
oh,
Yes,
right.
Yeah, that's just probably what's an idea. That's what I was trying to set up. So it searches for MVC first.
that's should I
Oh, MVHPC.
I don't know how we do that. This is what CMake just does automatically.
okay, so I should load one of them. No,
Yeah, try to.
but the mix this one.
We've CMake experts.
CC and stuff is set to GCC. So I'm not entirely sure why it's even. But it might be just like, I know about these.
Right. You probably say, I know about these compilers, if you find one of them, he's the first one.
Yeah, and the next might actually be that.
So then should I flame this?
Might
I'm
not,
not
it
sure-
might not be necessary.
I'm not sure it's necessary, but I always do it anyway.
Because that one time.
It is good about restarting. It does clean, if you go to my Mac, I'll switch like. The Mac's out.
think it's. But this is just. I think I just don't want to put this alone and it's
But if you want to see how Kokkos is built on Polaris, like for the public install, in the ALCF Support Center, under programming model, Polaris programming models, Kokkos, I was checking the exact CMake location he used to build on Polaris. Which probably just has
the support.
ALCF's getting started. It's also public install version. This is how we have Polaris right now. This has like options.
And if it's not working, it's good. Or-
That's probably the one for the older versions.
Oh, really?
Oh, it's on that.
Yeah, this is what I had put together. And that is, it's the one that's built in publicly is Kokkos 3. So it's some. So you're building the from the current one with people have 17 wired up. There may be
Is there anything breaking in 4.0?
The last time I tried it was many months back, and with the set of NVHPC kits we had then, I never could get Polaris. I'm actually coincidentally today trying to build Kokkos on board.
It was there, I showed you, right?
It doesn't seem to be too set up with NVHPC environment. At least when I was listening to the last couple of days trying to make sure it's up to date.
It's not, you should be able to use. I'm still trying to use CC.
Yeah, that's.
There's various versions. That would insert flag. I'd say there's newer versions that are.
Trying to get there. Then we just see me. It's supposed to be. There's customers that still need the other stuff. We never get there, but.
Test suite. Test without a following everything.
So I was used to use this as a compiler with NVCC wrapper. So should we or not? Should I use CC?
If you're using the GNU and HPC mixed, you can use the VCC parameter. So especially if you're trying to redo something you did updated, you would probably work better. But moving forward, we're moving with VCC, with WC plus.
It's
So right now,
it's just still supported, but. You know, you're using 5 minutes.
So should I specify?
I would specify.
Okay. And the same one as.
Yeah.
The same ones you used to do, you want to be as close to your old build as you can. Start with.
But when I built Kokkos, I didn't. So.
It's in the Kokkos.
Oh, it
install.
will.
You just need to pass it where to find that wrapper.
Yeah.
Because that's.
But that wrapper is part of Kokkos.
Building it up. We're downloaded Kokkos to when you figure out the CMake.
Because I built it like 2 years ago. Well, it was old.
Well, there should soon be some more recent build versions like 4.x installed centrally. And when we do that, when we get the configurations of everything working, then we can add that to the documentation. And
ideally you'd just be able to like link it. Yeah, the Kokkos on the system.
Right, but, you know, once we've captured the correct set of flags to do that build, then we can document that instead of what's in there now, which really only works with Kokkos 3.x.
The list of photos are roughly. When we do 5 of these, but it's 20 for us.
Or, yeah, they just use spec.
Well, commit it for your own code, right? But it's one of the languages you can have.
So you expect the dependencies here or not?
We do, we use it for some central installations. Obviously. Might be like a place where you can get some of that rooms installed by various you kind of building. Waiting from the bottom of it.
I don't know if that's built this lab, because it's back there.
Yeah.
You said.
The only issue with that is a lot of times the versions are kind of properly supported back. Who builds things a lot more support. Software. It's always my go-to when I try to figure out how to build something is to look at the spec pack. Yeah. I don't know if they put anything out or anything, but we do have a break scheduled for like the next 15 minutes, obviously. You're working in here, do whatever you want.
The snacks, that's the only good.
One question, so, do we need any extra, debugging module, like for C, we can use normal GDB, but, for the Kokkos, do we need anything extra?
So both Kokkos and Raja, since they're lowering to the other programming model, you can use that programming models debugging. So you can use CUDA-GDB, which is CUDA's or NVIDIA's version of GDB.
Right.
It's a simple version of GDB and Aurora.
But that's the other nice thing is that no matter what it lowers to, you
I
can
know
keep using the tools that work on it.
Yeah, I'm waiting, so
It's not like NCU profiling or code segmentation, as long as you're running.
And Kokkos has some also built-in profiling that you can.
More questions
We'll
coming.
keep track of like memory allocations.
In case, my code is actually, running on multiple nodes and I want to run GDB.
So there is a GDB for HPC, that's a parallelized version of it. Alternatively, you kind of can, so you can add it in through that command where you're firing off GDB through that. Stat, which is so, right.
And all of my occupied nodes.
All your,
Trace.
yes, all the nodes you're using. Only you can. Yeah, like you can use like regular, I mean, if you're on the CPU, you can use regular GDB, so when you have your nodes allocated, you jump to them and actually attach to the process.
Depending on what you're debugging, like sometimes it's easier to just make a CPU build, you know, like Kokkos like the serial backend.
Right.
But yeah, some other problems, of course, you need to get on nodes.
Unless you're unlucky, hopefully you can trigger your bug on a single node.
Yeah.
If it only shows up at many nodes, that's a big headache.
I
There's
never,
tools available.
I never done this, but hypothetically, if I'm offloading some part of the code on the GPU, and then if the bug occurs on the GPU, I want to somehow catch it, or I want to, like how my GDB run on the GPU. Is it possible, or it will run only on my?
So you'll see a stack trace to the kernel launch.
I know it's
Most
weird
of it
questions,
using
but I'm just like going
I'm
through all.
mainly using regular GDB, so I know what you see there. CUDA GDB should give you a little better information, but it's not like you can really do a stack trace on the GPU, so you're not gonna get like,
Understood.
you're not gonna be able to explore your variables. Do the things you want to do, but they do have support designed for the GPU. I'm just not super familiar with it.
Do I need anything additional to load the CUDA GDB on this? On the
No,
Polaris?
it should be in the MB HPC mixed.
Yeah, it
You
should be
can
the
just start
module, yeah.
typing it and see if it shows up. as GDP. And then just like tab. Yep.
Oh, yeah.
And this is like, it's a sits on top of GDP. So it's kind of arguments, everything you're familiar with, just NVIDIA's version that understands search.
Well, I can build Kokkos so much bigger out here than any machine. Just some ways sad. That's the way I can get the wattage usage up, because I have a little watt meter. I can get it over 100 watts. I'm doing Kokkos build. Because normally it's around like 20, like under 20 watts and draw.
Really just a terminal / power plant machine.
This is the first pass doing local Kokkos builds. It's just so much faster.
Playing. Publicly installed
Oh, I don't use the Apple. Yeah, I use the Homebrew one works. The Homebrew GCCs no longer work, and I haven't figured out why yet.
Yes. To be fair, I keep things, I don't update things well.
So many Homebrew, because every time I try to build a client, I've kind of forgotten like whatever. I'll get my options right, and I was just kind of like, I should write that down somewhere. And 3 months later, and I don't remember what those.
I mean, there should be some snacks out there from lunch still. That's why I said, I don't know if they put out more stuff for this break. You can check the sausage out there previously, coffee with stuff.
You generate, that is very less work.
That's how much being I used to snacks.
What we might. To the power 14, but to the power 14 actually. So the bandwidth that we have seen in this example is a memory bandwidth, isn't it?
Yes.
It is running on the single node.
Yep. That's, that'll be single node, single GPU. There, GPU.
Yeah, so this is like on the CPU one, this is bandwidth.
Yeah.
For the GPU ones, link bandwidth. Like they're using.
No, this will be the HBM bandwidth because you're on a single GPU, so
Oh, single GPU.
nothing's communicating
Oh,
across.
okay. Yeah.
Is there any example in Kokkos that actually uses that is more focused towards the networking? Like it uses multiple nodes and there is a lot of communication sometimes.
I'm sure there are implementations of it. I'm not sure if they're in the tutorial.
They don't really describe, you have to look into the code. They
Yeah.
don't really describe the every exercise. Yeah, I'll check.
Yeah, there's let me look. I know there's like integrating MPI with Kokkos examples, and that's what you're probably gonna want to be using. You might be able to pull some examples that use multiple GPUs in one process, but yeah, I'd look at the MPI. Yeah.
Sure.
So those should be running across no ranks, and then you can specify like, put this rank to use this GPU, this rank to use this GPU, kind of things. But you do need to specify that through setting the environment variables, or there's the CUDA set device inside that, which should do something with it already.
I'm just gonna bounce back over to the other. So if any other questions come up.
set of like little kernels. There's it's called parallel research kernels. It's essentially just like stenciled gem, like really basic kernels implemented in like a ton of languages, and there'll be a Kokkos implementation of that. And I know that at least one of those you can specify to use all the devices or control the device kind of through inline things like that. But you should be able to do it with the MPI rings because you want to have some communication happening.
Yeah,
Not just
that's
use everything.
where
Yeah,
my
yeah.
field comes in, and hopefully in the future paper.
Yeah, I didn't see anybody from the MPI team. I didn't really look too closely. I was trying to find out like what's going on underneath there because MPitch, we have an ALCF team that develops on it. Yeah, there's quite a few people. We had a few people leave pretty recently that were kind of network and MPI experts to do the MPitch implementation.
I am currently working, I'm not sure whether you're aware, so NVIDIA has recently launched this DPU, data processing unit, like it's kind of offload along with the CPU. Now they also have the GPU version of it, like you have your host machine, and with the PCI bus you have this extra card on which your NIC is situated along with the 8 cores. So you can offload the operations on this DPU, on these 8 cores, and let your host saturate. So that is something that I'm working on along with Argon.
Yeah. Yeah, that's kind of like the next step forward is the extreme.
Yeah,
heterogeneity.
that's why I came to you and asked you what kind of offloads do we have?
Yeah. So like at Argonne, we have the joint laboratory, JLSE, joint laboratory system evaluation, which is like just a bunch of nodes. That's where we get like every kind of new node that comes out that we want to play with. We get one, plug it in there. Nothing's like, there's nothing that has too much plugged into it. I think it was Los Alamos. I remember talking to somebody that had like a system they called Frankenstein, where they like just PCIe plugged in like everything to it. It's completely unusable. Like it's fun playground.
Sorry to bother you so much.
Oh, no worries. That's what we're here for.
For the Raja, we have to compile it, right?
For what?
For the Raja, we have to actually compile it. So is there anything else I have to do? So I'm following this one.
Yeah.
So I have done, and then CMake throws me this error. Builds are not supported. Okay.
It's,
There might be some.
there's the new line, so it's like cutting off the command that you pasted
Oh.
and running like the
Oh.
first line of it and then cutting it off. Cause it's getting.
Oh, okay.
My
Oh,
slide.
now
that
I see.
big,
Now I see. Now I see.
it's Getting the
You
return
got it
instead of like the
first.
back.
I saw that red thing and oh my god, what happened?
Yeah, so I didn't do a public install for Raja just because it's a little bit, it's mostly in the headers. So most of the projects kind of like integrated as a sub module for their builds directly. Cause Raja is really just focused on like the parallel execution. And then there's like other projects for managing your memory. So like you could use CUDA malloc at Raja, or you use like one of these other kind of APIs that they provide.
Do we have anything of a sort where right now we are explicitly telling these are the sorts of resources or these are the offloads that you should actually use, the program you should actually use? Do we have something which some sort of a tool in between or some sort of in between our compiler that will actually understand and optimize the code to run on different offloads or maybe perhaps different nodes?
So you're saying for it to like at compile time, look at what's available on the system and then generate code accordingly?
Yeah, I mean, on the compile time only we have to decide, right? This part of the code is going to run on the GPU and this is gonna be on the CPU.
Yep.
So, something of that sort, like we can maximum say our entire Polaris is free and we have the schematic. This is how the nodes are and this is how the CPU and these many CPU we have, these many GPUs we have. And then we give it the code and somehow it gives us the optimized version. You know,
I know, we do not have that. Do some research on that. So one thing is, MPI really doesn't do anything automatically, so it's like understanding how to decompose your problem. I think there's like Legion and there's a couple other like programming models for like across node problem decomposition that maybe would be able to do that. So you kind of always have to manually decompose your problem, like how to break up the ranks and everything, which changes pretty dramatically. As far as like what to run on it, I think I work with compilers, and one of the things there's like a research project from HPVM, which is just really setting it up so you can kind of target multiple things from within the compiler, because right now you kind of need to tell it right away. Because the way these compiler pipelines work is like they kind of outline and split their compilation pipelines immediately. So it's kind of hard for the compiler to do anything intelligent because it's already like, I'm just doing this or I'm just doing this. But like there's kind of some general source. So SYCL compiles down to like SPIR V, which theoretically can kind of go to different devices, go back and forth. It's just tricky because you kind of have to like set, it basically gets fully compiled. And then, so like really when you're switching these hosts, you kind of need to make some significant changes.
right,
So really you need to make a decision here and not just.
I mean, there should be like, instead of only having a communication while running a program, we need something that will communicate while compiling. I mean,
Yeah, like
something.
you need some schematic for like the actual target. But then in the code, you do need some way to specify basically like what you can decompose across. But that being said, some of those projects are like design where you kind of treat it as a single process and it just, you know, instead of like,
That's
oh, this needs to
actually-
communicate from the GPU to the CPU, it's like this needs to commute from this CPU to this CPU. So it works, it's just, you know, really slow because you end up with a lot of unnecessary communication.
But I think that will just, when we want to put multiple programs, so that will make our scheduler more effective, right? Or allocation even more effective. Because it will already know, since if all of my jobs are using the same compiler, somehow I can maintain a database where all these things will be logged, or somehow it will know if my program is running on this specific node, my new program, these are the requirements, it should run on this another sets of nodes. Like it will try to fragment them, you know what I'm saying?
Kind of. You're saying when
It's,
there's like
it's
different
just
devices
all
that do-
hypothetical discussion, right?
Yeah, there's a lot of work, so if you mean like for like different heterogeneous kind of devices. Yeah, so there's a work at Oak Ridge called Iris. If you want to look at it, it's kind of like a way to theoretically do this. I don't think it's so much about the deciding, as so much as it is literally just trying to have a way to get to the different devices. Problem is that like everything I've seen is when you like say, oh, I'm gonna enable it to be able to use this device, this device, this device. If the thing was written for a GPU, it's always gonna run best in the GPU, like. Like really, like you could write it to run better on this. But if you just start from the single, like you need to have some intelligence or code transformations to be able to like effectively use this accelerator. HPDM, like they just like, we're gonna offload every target we have, we're gonna like auto tune and see what works best. It's like, oh, it turns out the GPU that just has way more flops on this work best.
Just offload everything.
Yeah.
It's like, okay, all the kernels, we're just taking parallel kernels, right? It's like, you get an accelerator that can handle dependencies. But
Yeah.
What is the best way to reach out to you if I have doubt? Will email be fine from my school ID?
yeah, that's fine. I mean, at the workshop, I'll be on the Slack.
Okay.
This Slack channel will be active after the workshop?
They usually, I'm not entirely sure, but they usually keep it for like a
Couple of
week or
days.
something like that. So I would be surprised if it's like a hard cutoff. But yeah, email is fine. Assuming the email is on the website.
I'll find it. Thank you.
Thank you.
Good luck.
Well, yeah, I compiled hardware, but now.
Yeah, so, iPad, if you're using, CMake,
I have to use CMake because of the.
it's just specified in C compiler. I don't know why it tries to use the preprocessor as the C compiler if it doesn't get told what to use.
So I shouldn't use the wrapper then.
You should use that, but then just like dash CMake underscore C underscore compiler equals GCC. Even though you're not going to compile any C code, it's not going to get used. So CMake basically checks if all of its compilers are working. I don't know why it tries to use the preprocessor as a compiler, but basically it says, oh, CPP doesn't compile this code. So I'm not fully configured, even though you're not going to use the C compiler at all. You just want to define it for CMake.
Oh, okay, so it's just the CMake issue.
Yeah, CMake's trying to test something and it's picking the wrong thing to test, basically.
So I should specify the CMake C compiler as.
Just GCC. Yep. Seems like your code's using C++, so it's not going to actually impact your build at all. It's only going to be for that CMake check. And make sure it has a working C compiler. Let's skip the check to C compiler. Bus or like
So
regular.
we check, I mean, that part shouldn't be on. Yeah, it should be just regular, without GPU support. So
It's a cray side.
the leaves the case side. For
Please check real quick. Colleen talked about this.
yeah,
I was trying to remember.
I have the presentation.
Very lib side, but I'm not entirely sure. I'm assuming that includes the pack, but I don't.
Give example with plus. The debug example.
Looks like NVIDIA does offer CPU build. Oh, our Cray libsci also has it, yeah. But it's not called libpack, so looks like if you do like NVIDIA path/compiler/lib, it'll find it, and at least it's tagged as CPU, so they might have a CPU version.
Does this?
Yeah.
With the.
Um,
I
those are already in your build, because that's why it's looking for them. Oh, it's the same, okay.
think CMake
found loss. But it can't find it back. It might be like installed under a different name. I don't know if that's like proper CMake solution. I know sometimes like there's like CMARC class, you can specify it, but yeah, specify it.
And